All right, in this video, we are going to talk about the Cartesian coordinate system. So, the Cartesian coordinate system, or rectangular coordinate system, is basically just two number lines. One that's horizontal down here, that usually represents the variable x, and then a vertical one here, that usually represents the variable y. And those two number lines intersect at the 0 point. Okay, and they are perpendicular to each other. So, in other words, they form a right angle, and they intersect at the 0 points. And so, I'm sure you've probably seen that at some point before. Um, every point in that rectangular coordinate system, or plane for short, can be identified by a pair of numbers called an ordered pair. So we write ordered pairs in this notation, little set of parentheses right here, and then two numbers, right, with a comma separated there. You have to, so if we just talked about interval notation, and that looks a little bit like interval notation. So you do have to make sure that you keep the context on there. If we're talking about points in the rectangular coordinate system or the plane, then that probably represents an ordered pair. And if we're talking about solutions to inequalities, then that's probably interval notation. Okay. So an ordered pair has two numbers. The first coordinate here, and that usually gives the horizontal distance from of the point from the vertical axis. So like where the x coordinate is located on the horizontal number line. And the second coordinate, this second number here, 3 in this example, gives the location of on the vertical axis. Okay. And so if we, what we can do is, given one of these ordered pairs, is to graph it on the rectangular coordinate system. All right. And so it is an ordered pair, right? So the order does matter on these ordered pairs. So we want to graph this out. So, oops. All right, so I'm going to get this to where I can draw on it. All right, so we want to graph these ordered pairs, and so the first one is -2, -3. Right, so what we would do is go over -2 on the x-axis and then down -3, and then where we wind up, we would put a point right there. So that is the point -2, -3. So this tells you where to go left or right, basically the first number, and then the second number tells you how to go up or down. And for most people, that is the only confusing part. Once you remember this refers to left, right, and this refers to the up, down part, then usually pretty good on this. All right, so we want to plot the ordered pair 1, -4. So we would go over 1, right, on the x-axis, and then down -4. So that would be right here on this axis. All right, next up, -2, 1. So we would go over to -2 and then up to 1, and then that's where we would put the point, like so. 0, 0. Is right here, and that's called the origin. And then the ordered pair 1, 2, right, we would go over 1 and up 2, like this. Okay. And so given any ordered pair of real numbers, right, I can find some point that's specified by it. Even if they're decimals or fractions or whatever else, you might have to do that approximately, right? But every ordered pair, right, that we have of numbers will give us exactly one location. And they are ordered pairs, right? The order matters here. So if I have 1, 2, that was this point right here. And so if I look at the ordered pair 2, 1, you're going to see that that gives me a totally different location than this right here. So here I go over 2, up 1. Right, so that would be the ordered pair 2, 1. So on these, like the name implies, the order matters on these. Okay, and so that's it. So again, most people have zero problems with that, other than sometimes confusing, you know, the order in which these go, but it's the x number is generally the first number, right? And then the y value is the second number. Okay, so that brings us to equations in two variables. So an equation in two variables, right, obviously has two variables. For us, we'll usually be using x and y as the two variables in there. All right, so the equations that we were talking about before are just were equations in one variable, right? That's what we started out talking. So now we have equations with two variables. So a solution of an equation in two variables is an ordered pair. So it's a number for one variable and another number for the other variable. Okay, and again, generally when we're talking about ordered pairs, the first number is the number that you would plug in for x, and the second number is the number that you would plug in for y. Okay. All right. So if I want to test to see whether an ordered pair is a solution of the equation, it's pretty straightforward. All you have to do, just like we talked about in the previous lesson for equations with one variable, right? If I want to test to see whether or not a solution, an ordered pair is a solution of an equation, then what I would do is just take the first number and plug it in for x everywhere it appears, and the second number and plug it in for y. All right, and when you do that, when you plug these specific numbers in for the variables, right, then what happens is you get a statement, right? Or remember, that is something that's either true or it's false, right? And so here we can see that if we simplify both sides as much as possible, right, we get 2 equals 2, which is absolutely true, right? That is a true statement. And so that would mean that 1, 2 is a solution, right, of this equation. On the other hand, right, if I ask, hey, is the ordered pair 2, 1 a solution of this equation, right, then what we would do is plug the 2 in for x, right, into the equation with two variables. So everywhere there's an x, we would plug in a 2. Everywhere there is a y, we would plug in a 1, right? And when we do that, we have just numbers on both sides, and so we can tell whether that's true or false, right? In this case, this is saying that 1 is equal to 3, right? And so that is false, right? And so our conclusion, right, is that the ordered pair 2, 1 is not a solution of the equation. So if I have some equation like this, and it's pretty easy to tell whether an ordered pair is a solution or is not, you just plug it in. If you get a true statement, it is a solution. If you get a false statement, the ordered pair is not a solution. Okay. All right, so another big difference about our equations with two variables, a big difference from the equations with one variables, is that a lot of times these equations with two variables have infinitely many solutions. So that makes it really, really hard to find every single possible solution or to list them out. In fact, that actually can't be done to list them all out, but that's a topic for another day. So so just to show you, right, on that this equation has infinitely many solutions, right? If I take any number and plug it in for x here, let's say I plug in a 2, right, for x, I will be able to find some ordered pair three over here. So that gives me that 2, 3 is a solution of this equation. So already we have 2. We have 1, 2, and we have 2, 3. If I plugged in a 3 for x, I get y equals 4. So that would give us a solution of 3, 4. All All right, and hopefully it's not very hard for you to imagine, if I plug in any number for x in here, I am going to get another ordered pair solution. So in fact, there are infinitely many solutions, right, of this. And so, like I said, writing those down is not really feasible. It's a lot more solutions. And previously, those equations that we've been talking about with one variable, the ones that we studied have had maybe usually one, right? Sometimes zero solutions. So having infinitely many is a lot more complicated. And that's not to say an equation with one variable can't have infinitely many solutions. It can, but most of these, a lot of these equations have infinitely many solutions. That's more of the norm on these. All right. So the question is, well, how do I get a handle on all those solutions? One way in which you can do that is to sketch the graph of an equation. Okay. And when you sketch the graph of an equation, it basically gives you a little picture of what the solutions look like. Okay. And looking at that picture, it's just a lot easier to kind of just get a little snapshot of what the solutions look like. Whereas if you tried to list them all out, it's not practical at all, and it's not going to give you a very good picture of what it looks like. Okay. So to graph an equation like this, what we want to do is just start with some numbers. So let me take a picture of this. And what we're going to do is make a little table, right? And we are going to pick some numbers to plug in for x in here. So on this particular one, I'm going to pick -2, -1, 0, 1, and 2. All right, and so the question always comes up here as well, how does you know how to pick those numbers, -2, -1, 0, 1, and 2? And that is kind of a complicated question in general. Here, these are good ones to start with, but these are not going to work for every single possible equation. And so that's kind of a downside, but for right now, this is what we're going to talk about, of how to do that. And moving forward, right, really we're not going to be doing this by hand a whole lot like you used to have to do it by hand a long time ago. And the reason is because these days, right, we have computers and calculators that can draw these graphs for us. But it is very, very important that you understand, really, the most important thing is that you understand the connection between, right, this equation with two variables and the picture that it generates. All right, so don't sweat the details on how I pick these. For the ones that we're doing, these points for the most part will be okay, but as the graphs or equations get more complicated, then that also becomes more complicated. All right, so what we do then, just like we were doing in the previous slide, is we basically generate a solution for that value of x that we have. So take this number -2 and I plug it in for x. So when I plug it in for x here, I get -2 quantity squared. When you raise -2, right, or any negative numbers, when you square those out, you have to be very careful about how you do that. And so my advice to people is generally put those the negative numbers inside parentheses. All right, so because the correct value here is -2 squared is +4. All right. Because -2 times -2, right, a negative times a negative is a positive, right? That's what -2 squared stands for, right? It is -2 times -2, which is positive 4, right? Because a negative times a negative is positive. What ends up happening, right, where people kind of go wrong on that is that they will do things like go to the calculator and just plug the number into the calculator like so. They'll do -2 squared, right? And you can see it gets -4 right here. So you can't just blindly plug it into the calculator like this, right? The correct way is plugging it in like this, and you can see you get the correct answer here. And now a lot of people's reaction when they see that is, well, why? It should be like this, right? It should work that way. But this should be the one that comes out to be +4, but it can't be like that, right? When the calculator sees this, right? Oops, sorry, wrong problem. When the calculator sees this, right, it only assumes that that square is on the 2. So it treats it like this. Oh, you want me to square 2 and then take the opposite of that. And so that would be 2 times 2 is 4, right? And you have that negative in front of it, like so. All right. So remember, if you're using your calculator on this, if you're raising a negative number, right, to a power like this, you need to have these parentheses around it. Okay, so over here we get a 3 on this one. So the ordered pair would be a 3 here. Next up, I'm going to plug in that -1 for x. And I get 1, -1 quantity squared is 1. So I get 0. Let's see, I'm going to erase these. All right, then I plug in the 0. And 0 times 0, 0 squared is 0. 0 minus 1 is -1. Now plug in the 1 for x into the equation. 1 squared is 1, so I get 0. And then plug in the 2 into this x. I get 4 minus 1, which is 3. All right, so you can see what I'm doing is just generating a bunch of solutions that look like this. So once I have all of my solutions down, then I plot those ordered pairs, right? -2, +3. -1, 0. 0 minus 1. 1, 0. And 2, 3. All right, and if you keep plotting a lot of these, then you basically kind of get the shape of the graph. If you took time to plug in a bunch of numbers and do this, right, you would get the graph that looks like this. And that's really badly drawn, so you're just gonna, oops, actually I messed that up, sorry. All right, let me erase that. Sorry, I had that point too high there. Sorry, -1, 0 right there. All right, and now we can draw it there. That looks better. It's weird drawing on, using my mouse to draw. It's not the greatest. All right, so that looks better, okay? So again, we're not going to be drawing a bunch of graphs by hand, right? Because technology will allow us to do things like in Desmos, right? I can just type that equation, y equals x squared minus 1, and you can see I get a nice graph with hardly any effort at all, okay? And you can see it has those points that we had on here, 0, -1, 1, 0, -1, 0, and minus 2, 3, and 2, 3 over here as well. Okay, so you get really nice picture. So again, we're not going to be doing this by hand a whole lot. What I really need for you to understand though is the connection between this equation, right, and the graph. What does it mean, right? Basically what it means is that if I take any point that's on this graph at all, right, whatever the x and y number is, say I pick this point, right, that point is going to have an x number and a y number, right? It's hard to see what it is on this because it's not on one of the grid lines. But whatever the x number is, if I plug that number in for x and if I plug the second number in for y, I am going to get a true statement. It is a solution. And then if I pick any point that's not on the graph, right, over here, like this point, negative 3, 0, if I plug the negative 3 in for x, right, that point is negative 3, 0. So if I plug that negative 3 in for x, and if I plug that 0 in for y, I'm going to get a false statement, right? It's not a solution. So I get 8 equals 0, which is false. All right? So what this graph is a picture of all of the solutions of this equation. And there are a lot of them, right? Infinitely many. So yeah, this has infinitely many. You can't really list them all out, but you can generate this nice picture, right, of what all of the solutions look like. All right, and that is very helpful and useful in algebra and math. Okay. All right, so the general idea for graphing equations with two variables: pick some values of x. Again, we're really not going to do much of those, but plug the values in for x and then solve for y. That's going to give you a bunch of ordered pairs like we had in this example here, and then you would plot those ordered pairs in the places where they're supposed to go, right? Not off one by like I did, but and then basically kind of connect the dots to generate the graph, and that gives you a nice picture of what all of the solutions look like. Okay, I think we're going to stop this video right here, and then we will split the distance formula off into the next video.